Hello, ladies and gentlemen. This is Miss Stratton. Today we're going to be learning about atoms and elements. So, atoms are going to be our focus for the first part of this note taker. So, all matter is made up of tiny particles called atoms. So, you've talked before about what matter is. Matter is anything that takes up space and has mass. So, the desk that you're sitting at takes up space. It has mass. It's made of matter. You are made of matter. Your dog is made of matter. The air that you blow into a balloon is matter. Now, air and gases are kind of tricky when it comes to talking about matter. That's where people get stuck sometimes because we don't think of the air around us of having mass, having weight, and it doesn't have much. But a good way to remember that gases are matter is to think about blowing up a balloon. If you blow up a balloon, the air that you're putting inside of that balloon obviously takes up space. And it doesn't have a lot of mass, but again, it does have some mass. So all matter, anything that's matter, is made up of atoms. So atoms are made up of even smaller things called subatomic particles. And those subatomic particles we're going to be looking at are protons, neutrons, and electrons. Those are the three subatomic particles in an atom. The first one we're going to look at is a proton. A proton is a positively charged particle in the nucleus, and protons have an atomic mass of 1 AMU. AMU just stands for atomic mass unit. So our protons are going to be these little positive guys in the center of the atom, and that center is called the nucleus. So protons are positive. You can remember that because they both start with P, and they are here in the nucleus. Now, the number of protons determine the element of an atom. So an example here is that hydrogen has 1 proton. Helium has 2. If you have an atom that has 1 proton, it's going to be hydrogen every single time. If you change the number of protons, you're not looking at hydrogen anymore. You're looking at a different element. So you can't take protons away. You can't add protons because then we have something different. Now, electrons are the next type of particle we're looking at. Electrons are the negatively charged particle in the electron shells or the levels. We even call those electron clouds sometimes. So electrons are negative. You can see that with a little negative sign on there, and they are really, really small. So the mass of an electron is 1/1850th that of a proton. So it doesn't add much mass to the atom at all. In fact, we don't even count it when we're looking at atomic mass. So remember, electrons are sort of on the outside in this cloud, and protons and neutrons are in the middle. So neutrons are the neutral particle in the nucleus of an atom. They have no charge at all and have an atomic mass of 1 AMU, just like protons do. So our neutrons are in the nucleus with our positive protons. Now, hydrogen is the only element that doesn't have at least 1 neutron in its nucleus. Everything else has 1 or more neutrons in the nucleus. Hydrogen is the only one that doesn't. Now, atoms are mostly empty space, which is really weird to think about because that means that you are mostly empty space. So when you think about something being empty, you probably normally think of like a room that's empty or a jar that's empty or something like that. But chances are those things are not actually empty. They're probably full of a gas. So when we're talking about empty space in an atom, all this space that you see right here really and truly is empty. There is nothing there at all. So the mass that we do have in our protons and neutrons comes mostly from the protons and the neutrons. The electrons, again, are really itty bitty bitty tiny, and they don't really factor into the mass of the atom. So now we're going to be looking at elements. An element is just a specific type of an atom. When you think of dogs, you have German Shepherds, you have Collies, you have Border Collies, you have Pekingese, you have Shih Tzus, and those are all dogs, but there's specific kinds of dogs. Elements are the same way. An element is just a specific form of an atom, just like a German Shepherd is a specific kind of dog. So, an element is a substance that cannot be broken down into a simpler substance by chemical means. So, all that means is if you break this magnesium element down, it's not magnesium anymore. It's just going to be a proton, a neutron, or an electron. And the proton in magnesium looks just like a proton in gold. An electron in magnesium looks exactly like one in silver. So you can't break an element down any simpler and it still be that element. So elements are composed of atoms that have the same number of protons in their nucleus. So again, we said a second ago that if you change the number of protons, you change the element to something different. Magnesium will always have 12 protons every single time. If it doesn't have 12 protons, it's not magnesium. And again, those protons are in the nucleus. So every element has a unique atomic number, and it tells us how many protons are in the nucleus of the atom. And that's going to be a whole number that you find on your, on your block on the periodic table. Sometimes it's going to be in the center, sometimes it'll even be at the bottom, but it's always going to be a whole number because you can't have pieces and parts of a proton. So normal atoms are electrically neutral. So that means they have the same number of protons and electrons. So this magnesium atom, if it's neutral, it has 12 protons and it has 12 electrons. You guys learned in math that when you add a positive and a negative, that's going to bring you closer to zero. So if you have 12 protons, you have 12 electrons, that's going to give you a neutral charge, no charge at all. So every element has an abbreviated symbol because nobody wants to write out magnesium every time they're looking at the element. It's a lot easier to just write Mg. So at this point, all of our elements have a chemical symbol that's either 1 or 2 letters. Now, the first letter is always going to be a capital letter. If it only has 1 letter, that letter is going to be capital. If you have 2 letters, the first letter will be capital and the second will be lowercase. The first letter is always capitalized, and the second letter is lowercase. Now, some of the symbols just make sense. We look at magnesium, Mg, magnesium. That's the first 2 consonants in the word magnesium, so that kind of makes sense. But some of them don't, at face value, look like they make a lot of sense. So, for example, what they said here was that iron is Fe, and it comes from the Latin word for iron that is ferrium. Another example of that is gold. Gold's chemical symbol is Au because the Latin word for gold is aurum. So if you see something that doesn't make a lot of sense at first, if you do a quick Google, a lot of times you'll find out that the Latin word for that element is the base for the atomic symbol. So every element has a unique name, and some element names are really old and are based in other languages. So, for example, chlorine is named after chloros, and it's the Greek word for yellowish green because pure elemental chlorine is a yellowish green element. So, newly discovered elements are named by the discoverer, but they have to be approved by the International Committee. So, my gamers might think this is kind of funny. So, element 117 was created in a lab, and the team that created it actually put up the name Master Chiefium. So if you've played Halo, you know that 117 is Master Chief's number. It didn't get approved. It was actually wound up being called Tennessine because it was created in a lab in Oak Ridge, Tennessee. So the atomic mass is the next thing we're going to look at. So the atomic mass is the mass of the protons and neutrons in an atom. Every proton and neutron has a mass of 1 atomic mass unit. That's not something that's going to change. So notice that we're only counting protons and neutrons because those electrons are so teeny, teeny, tiny that they don't really affect the mass of the atom because, again, they're so, so small. So the mass of an atom can be shown with a decimal because it's an average of the isotopes of that element. Now that sounds kind of complicated, but really it's not. So an isotope is just an atom that gains or loses a neutron. So neutrons don't change the charge of the atom, they only change the mass. So sometimes we gain neutrons, sometimes we lose neutrons, and so what we do is we average out the mass of that. So this is not a true mass. This is just an average because you can't have pieces and parts of protons, neutrons, and electrons. This is just an average. All right, ladies and gentlemen, that's all I've got for you right now. So we'll discuss this a little bit in class later. It was great to give you some information, and I'll see you later. Bye.